Welcome to a tutorial on how to use the Residential Electrical Service Upgrade Decision tool for individual homes. In this video, we'll go over how to use this tool to avoid panel upgrades and review panel impacts and recommendations for electrifying homes. To begin, navigate to the Instructions and Info sheet. This sheet contains a list of instructions on how to use this tool and additional guidance on the home electrification and NEC calculation procedures. It is important to remember to go through this tool chronologically through the sheets. Each sheet is identified in the recommended procedures with a description on how to use that sheet. Additional guidance is located on the sheets themselves, as we'll see later in this video. Property information. In this sheet, input the location of the property and other information that is available for the property. Use the legend on the right side to determine which cells require inputs and which cells have optional inputs. Any grayed out cells are calculation output values, and no inputs are permitted. Some cells have drop-downs, which display a list of available options that you can choose from. Existing system and loads. To begin, input the existing building system information below. There are two categories of inputs: those likely to have electrification retrofits and those that will not. Start with the left column and indicate a yes or no on each building system that is present in the existing home. This sheet is pre-populated with default values for systems that are typically targeted for electrification upgrades. Edit the blue cells with information from the drop-downs that are specific for the residence. The tool will make some basic assumptions of the wattage of each device as the device type is selected. If the user has more specific data from equipment nameplate or manufacturer literature, toggle Use Default to No, and manually input the voltage and amperage for the device. It is important to include wattage information of gas-powered devices that have electrical connections for controls and fans. Though the wattage may be low, this information impacts the existing building NEC load, which becomes the baseline reference for the residence. To add other large loads, such as a spa, toggle Other Large Loads 1 to Yes, and input the type, main energy source, voltage, and amperage. If there is no intent to conduct electrical upgrades on an additional device, include the device in Other Appliances under Fixed Appliances to deem the load as an unchangeable base load. After filling out the first category that contains the systems likely to have an electrical upgrade, continue to input the existing electrical loads that are not impacted by the electrical retrofit. These loads will not be changed through the electrification process and won't be optimized after this initial input. The general loads are dictated by the NEC calculation process and define lighting and receptacle circuits that are present in every house. The default number of appliances and laundry circuits is dictated as the minimums according to the NEC code. If the residence has more than the default, the number should be updated to reflect the actual conditions of the residence. The remaining fixed appliance loads are intended for hardwired appliances and devices called out as requiring dedicated circuits. Any additional appliance that fits this criteria and is intended to remain unchanged should be added as other appliances. Electrical upgrades. This sheet contains inputs for each building system that will be upgraded or electrified. Just like the existing system and loads sheet, Select Yes or No in the Upgrade/Electrify Systems column and input the correct information using the drop-downs in the cells colored blue. You will notice that the existing general loads and fixed appliances are missing from this sheet. This is because the general loads and fixed appliances remain unchanged and will not be upgraded or electrified. Panel impacts and recommendations. This sheet summarizes the panel load calculations for the residents and confirms if a panel upgrade is necessary to be able to handle the planned electrification upgrades. If the electrical upgrades causes the loads to exceed the current panel's capacity, use the optimization tabs to determine which optimization is best for the residents. Option 1. Low power appliances. Using low-powered appliances could be the most cost-effective method to meet panel capacity. On this sheet, select one or more of the following low-powered appliances and input the correct information in the blue cells. When finished inputting this information, check back on the panel impacts and recommendations to see if you need any additional optimizations for your project. Option 2. Right-sized HVAC. Many legacy HVAC systems are oversized to ensure the ability to meet heating and cooling demands. However, with proper installation and other envelope improvements, oversized HVACs can be reduced to minimize electrical loads on the electrical panel. Toggle Yes for systems that can be reduced. Additionally, consider removing the strip heat backup. Electrical strip heat is commonly included in a heat pump system when purchased, but often unnecessary in California. The strip heat is used as backup heat for very cold climates where heat pumps don't function as well, and to provide heat for condensing coil defrost cycles, both of which are rare in California. Option 3. Load management and dynamic EV. This sheet contains 3 strategies that can only be viably implemented independently. For this reason, select only one option to run calculations and check the panel's impacts and recommendation sheets to view results. The calculation for all 3 strategies can still be viewed in the current setting results table, but only the selected strategy will be applied to the load calculations. Complete the selected option by inputting the correct information in the blue cells of the corresponding section. Sharing an EV charger and another circuit. This is an effective approach when a residence has 2 loads that are similar in size and can be scheduled to operate at different times. Dynamic EV charging. This approach effectively eliminates the EV charger load during high power consumption periods and replaces the load during low power consumption periods. Note that not all EV chargers are capable of dynamically managing charging speeds and that charging times during peak hours will be unreliable. Smart panels or breakers. This approach is an effective way to manage all loads in the house to trim usage during peak hours. This solution can be expensive, since it will require rewiring the main electrical panel and will involve utility disconnection and reconnection, but may be a good choice if the customer has or intends to install solar panels with a backup battery system. Select which systems can shed or share loads in the left column. Systems that are not recommended to shed loads are indicated in red. Once the desired options are completely filled out, check the panels and recommendations sheet to view final results. Panel electrification results and optimization recommendations are found on the right-hand side. This completes the tutorial on how to use the Residential Electrical Service Upgrade Decision tool for individual homes.